So no, my sailboat is an aluminum boat.
Oh, okay. Okay. Great.
Yes, my sailboat is aluminum boat. Just to check here. So we are recording the Zoom, right?
Yeah, I am recording.
That's good. Yeah, that's good,
And,
because then I have a record as well. Very good.
no
Yes.
problem.
So it is a aluminum boat, and this boat was delivered in France in 2016. So it is kind of a new boat, and
Correct.
so the factory is a well-known, has a very good reputation. So it is called Boreal, the name of the
Boreal.
company. Boreal.
Boreal. Okay. Let
Boreal.
me ask to you a question. That boat is
Yes.
the power is considered European power, 230 volts, 50 hertz, no?
Yes. Yes.
Okay. Okay.
Yes.
All right.
So a little bit of the background. So a very good reputation company, made in France. So so the boat was delivered to me. I'm the only owner in 2016, and then for the 3 first years, I sailed a lot with the boat. So in the North Sea, in the Med, in the Pacifico, I went to Easter Island. I went to Patagonia. I went around
Nice.
the Horn.
Nice.
Yeah, and then I stopped in Uruguay.
What type of
So
engine? What type of engine have the boat?
the engine is a Nani engine,
Yeah.
65 horsepower. So then in 2019, early 2019, I left the boat here. So the boat was out of the water for the whole time. The boat was on the hard, so the props that hold the boat right out of the water, they are wood, so there's no metal in contact with the boat while the boat was out of the water.
Correct. When you say that the boat was out of the water, was located in a pedestal, in something like this?
Yes,
Okay.
that's correct. And
Okay.
what I'm explaining also is that the props to keep the boat out, right, can keep the boat balanced out of the water, they're made of wood, because in some places there are some metal cradles, and that's not the case here. Now here they just lift the boat, they put a lot of wood and keep the boat wood.
And any part of the keel of propeller touch the water?
No, there's no water. It's completely out of the water.
All right.
It is the surface here. It is concrete floor.
Yeah. Okay. And I have a question. When the boat was out of the water, the boat was connected to the pedestal in order to keep the battery charger working, or not?
No, I never, because I'm very careful, because it's aluminum boat. So the boat was never connected to the pedestal, was never connected to shore power. So to keep the batteries charged, I have a solar panel.
Oh, okay.
And the solar panel kept trickling charge to the batteries.
Yeah. All right. Okay. And you never try to do a practice that I recommend, is that with a cable, with an alligator cable, connect the ground of the boat, the negative bus bar of the boat, to the ground of the building, the ground of the marina, the ground of. You never do that?
No, because no, I don't. But I also thought that as the boat is completely out of the water, that was enough to isolate the boat.
No, with wood. The boat is isolated with the wood. I understand. No.
Yeah.
Okay.
So then a little bit more about the electric system of the boat, and so I mean, this is a expedition boat, right? So this is so this is not a simple boat, honestly. It has a lot of electric components here. But in terms of battery banks, so the boat has 3 battery banks.
Correct.
So there is one battery for the engine.
Correct.
And the
Cranking
generator.
batteries.
The
Correct.
cranking battery, yes. Then there is the house batteries, which are separated. Then I have a bow thruster. The bow thruster operates with 24 volts,
Correct.
as opposed to the rest of the boat, which is
Correct.
12 volts.
Correct.
So the bow thruster has 2 batteries, which are kept in more towards the bow of the boat.
In the bow of the boat.
Yes. So when I got back to the boat, so what I did when I left, all the breakers were turned off. So the engine breaker, the engine battery breaker was turned off. The house battery breaker was turned off. By the way, all the breakers in this boat, they take care, are double pole. So they break both negative and positive.
They are interrupted, both of them.
Yeah, both get interrupted. Correct. Then so for the bow thruster, the system to the breaker, it's not a manual one. It's one that there is a digital display, and I touch that, and it triggers a relay that
and the relay open or close the breaker.
Exactly. For sure, I feel very confident that all the breakers were closed, because that's for me, like the ones that are manual, it's visual, so I can see there that I closed, I switch it off. So the one for the bow thruster, it's one that I am very confident, but as it is a digital display, I always have in my mind, oh, was it did somebody working on the boat left that open or not? Okay, so I don't know, but I would say that with 98% of chance to be right, that was turned off as well. Does it make sense?
I have a question. Of course, makes sense. And your explanation is clear. Thank you. Let me ask to you a couple of questions. Are you sure, 100% sure, that when you have all of those breakers off, all of them, you don't have power in the engine, in the harness of the engine, or probably?
There is very, very minor. It's like it's, I don't know, maybe I don't remember the number on top of my head, because what happens when I turn off all these breakers? So there is still a digital display, a very tiny digital display that remains on. Right?
Yeah.
So which is minimal.
Okay. Remember, Joao, remember that you need a current less than 1 milliamp flowing constantly in between the metals to accelerate the phenomenon of corrosion. Less than 0.001. This is practically nothing, no? If you have a little more than 0.001, the phenomenon of corrosion in between dissimilar metals together, you have a lot of dissimilar metals together in the boat. If additionally you have current passing through those dissimilar metals, you accelerate the corrosion in those elements. For that reason, I asked to you if you have a small current flowing through the harness of the engine when the engine is completely off, when the engine is completely disconnected.
Okay, so now I have some pictures of the anodes here. So this is how it looks like.
Correct. Correct.
Okay. So what you're saying is that here, so the connection around the boat here, it's not super important that connection has contact with the anode. Is that correct? So
That's correct.
That the most important place really to get contact with the anode is the nut that screws the anode in place.
Correct. Correct.
Okay,
correct.
got it. Okay, so in terms of because I was with the impression that I needed to clean that area.
Joao, you see the area, the neighbor area in between this, the contact in between the sacrificial anode and the hull, and is highly corroded. You see that area in the edge.
I see.
This is because the direct contact in between the sacrificial anode and the hull, and probably those sacrificial anodes are in a sink. If it's not good. Okay.
Okay. So yeah, this is the
exactly. They should be separated. Should be separated like this. Correct.
Okay. So sorry, just to make sure. So here, in terms of installation of the anode, we have the question that if this is anode is the right one. But in terms of install the anode, the installation from the outside, it looks correct to you.
Correct. They should be they should be separated. That's correct.
Here it is. You see here. That's the place where I was saying that has no contact with the hull, because there is a hole here, a depression here.
Correct.
Yeah. So, and I was, and the local guy, he was saying that it would make sense, and I believe that you speak Spanish as well, right?
Yeah, yo hablo español. Yeah. Sí, no problema.
Okay. So arandela. So he was saying that it would make sense to put an arandela, so a washer here inside, so that we would increase the connection with the hull.
Correct. You need to be careful with the material of the arandela, the material of the washer. The material of the washer should be marine grade stainless steel. Should be an stainless steel series 300, 316 is the idea. Should be marine grade stainless steel washer. If you use regular arandela in a regular steel covered with a zinc plate, this is the worst scenario. You accelerate the corrosion over there. Current, try to use the pad with less resistance.
Yes.
Correct. If the idea is that you create a bonding system with a bonding conductor and sacrificial anode that provide the less resistance as possible. Why?
Correct.
Because you select an appropriate material for the sacrificial anode according with the water and the metal of the hull. That metal is excellent because the oxygen in the water prefer attack that metal instead of the aluminum. In that case, the path of the current is excellent through the bonding conductor and the sacrificial anode. No, if I select a sacrificial anode not appropriate for my boat, I create too much resistance, and the current goes and try to drain directly through the hull.
Okay, so I will make sure here that that I'm explaining myself correctly. So this is my. There is the battery here, right? Negative and positive and negative. Then there is the engine, and this is the hull.
Correct.
What I'm saying is that if I measure the path from the negative terminal to the hull, I'm getting 1 kilo ohm.
No. Okay. You have one ohm. You have 1200 ohms, no?
1000 ohms.
1000 ohms. Okay. Okay. This
So,
is good. This is
yeah,
good.
I believe that, is it good? It seems
this is good because it's high resistance. That's good.
exactly. Could yes, that's high. That was my point.
Correct. This is good. That area is good. Is good protected. You need to do the same with the batteries of the bow thruster, and check the resistance in between the negative and the hole in that point.
Yes, that's what we will do. So let me stop that. There is something different going on. Yeah, it was my mistake. I was with the double pole breakers turn it off, right? And then of course then I was not finding.
Correct.
Yes. So, but yeah, at least the double poles are working.
Yeah. Try again.
Yeah, here it is. It's the same. It is a 1 kilo ohm of resistance.
Correct.
And that sounds appropriate to you.
This is good. This is good.
Okay,
you need to verify in the bow of the boat.
Okay, I will verify in the bow of the boat. And also to find the potential between the hull and the positive, it's normal also, because if there is
the only way to do that is with the silver chlorine electrode. I don't know if you have a silver chlorine electrode.
No, that's to do in the water, right?
It's with the boat on the water, and I am going to send to you the video to use the silver chlorine electrode and the procedure to check the potential difference.
I see. Any other test you would like me to do right now, or let's wait and then reconnect after it is connected?
No, for now, the recommendation that I did, please follow those recommendations, and we can schedule other conversation.
Okay, all right. And for the bonding we need to, so is it what will I need to in terms of a material to,
for example, you can create a traditional bus bar, big one. You can install three elements like this: one in the engine compartment, other in the cabin close to the bow thruster, and other in the back of the boat. And you connect all of them together and connect it with the external sacrificial anode. That's it. That's the connection.
That's it.
That's it.
I see. So I will only need those heavy gauge, large cables, and the bus bar, and then I will need to find to connect with the sacrificial anode. So I don't know if those bolts are just welded in the hole.
No, you remember that both bolts pass through the hole, and in one of the bolts you put a washer with the big cable connected to the bonding conductor. That's it.
I see. So I need to identify where that is to see if there is some bolt inside the hole. Hopefully, because if there is, then the connection is simple.
Minimum one bolt pass through the hole completely.
Okay, I'll try to find that. All right. Okay, good information. We will schedule another one to make the tests on the bow.
No problem.
Okay, thanks a lot.
Thank you very much.
Should I call you Mr. Lopez, Alvaro Lopez?
Thank you.
How should I call you?
Alvaro, whatever, no problem.
Okay, Alvaro.
Okay.
Thank you, and we'll be in touch.
Okay. Thank you very much. Have a good one.
Bye.